Hello, welcome to my dissertation presentation. This is the title of the dissertation: Verification and Performance Evaluation of Bank's Cloud Recovery System in Hadoop Free. My name is Luton. My supervisor is Prof. Adwati. Next part, I will introduce the project background. Nowadays, most commercial banks adopt information system. Data is as important to banks as life. However, there are still attacks or disaster on the bank information system, which will cause the system of bank to break down. Thus, bank service is first to stop. To ensure the stable operation of bank system, the construction of the disaster recovery system is necessary. In recent years, the development of cloud computing and other new technology has brought new challenges or opportunity to the construction of disaster recovery system. Generally, as a resource for disaster recovery, the cloud greatly reduced the cost, difficulty, and complexity of the disaster recovery system, and it will improve the convenience for the research problems. Traditional disaster recovery contribution is limited by technology and cost and face some problems. Traditional recovery system require a large amount of investment. The original technology, mechanism, and mode are no longer applicable during the transformation of IT architecture from the traditional to cloud architecture, and a new disaster recovery technical architecture is required. Using traditional disaster recovery system technology to store or recover data require a high cost. With the development of cloud storage and big data, cloud disaster system can be used to back up and recover data, greatly reducing cost and improving performance. As for the objectives in this project, the first, to build a high availability system in Hadoop free work and verify whether the system can be used. The second one is to measure the performance indicator recover project and recover time objective of the disaster recovery system and analyze the result. The last one is to compare the result with traditional disaster recovery system such as hot standby, dual active disaster recovery system in architecture, performance, cost. Next part is for project scope. The scope of this paper focuses on how to achieve a traditional disaster recovery system and the cloud disaster recovery system. Study the math of data recovery and the model of data memory to build and verify a high availability system in Hadoop free work. Cloud disaster recovery system has better performance and low cost than traditional disaster recovery system. This study researched the difference between the traditional one and cloud one such as the hardware, architecture, cost, and performance. This is our timeline, and the next part is for literature review. Actually, the data center get more revolution in 5G network. The traditional one is often make of tens of thousands or hundreds of thousands of servers. But now you can run the servers or resource from the cloud company. The next part is recovery systems network construction. It includes the network structure, network application, network traffic characteristic, network virtualization, and this part is for Hadoop 3 free. I will use the MapReduce, HDMS, Yarn, Runkeeper in following paper. Next part is introduce the difference between the traditional recovery system and cloud recovery system in network structure. In the network structure, the traditional one often use the three-layer network structure, and the cloud one get more choice like factory, virtual. As for the network application, the traditional one often need to build by yourself, but the cloud one you can rent from the cloud company. As for network traffic characteristic, the traditional one is often used the point to point, but the cloud one get more choice like one to one, many to many, many to one. As for the network virtualization, this is the basic technology in the cloud system. This is for Hadoop free components. The first one, MapReduce, is like a calculation free. You can run the service in MapReduce. You can do some calculation in MapReduce. As for HDFS, it often used to save data, make replications, or operating date. For the Yarn, it is a container. If you wanna run the task, you need to run on the container. The next part is for research methodology. First, I will decide the traditional recovery system, decide the cloud recovery system, build and evaluate the recovery system. And then I will comparing in performance cost architecture between them. And the last, I will analyze the resource. First, this is the traditional recovery system designed by me. You can see that the bank server in the left part, the right part is traditional recovery system. You can see that it's very similar because the traditional recovery system is like a replication for the back server, so it means high cost. The next part, as for the detail for traditional recovery system, the main server and disaster recovery data center are decided to adopt the connection model to do computer hold backup when the main server is in disaster. Disaster recovery server provide the operation of service in real time through the mode of dual computer hold backup. Synchronous replication is adopted from the storage driver of the master server to the storage driver of the disaster recovery system. The server adopts a storage area network connection to the storage area. The SAN has high access speed, strong data backup capability, and strong scalability. The next part is for cloud recovery system designed by me. You can see that the architecture is easier than the traditional one. It just make of virtual servers, and the virtual server will deploy in the cloud company, not in the bank. In the cloud disaster recovery system, only high-speed network connection is required and some hosts from the cluster. Virtualization technology is open up one only resource on server host, including computing resource, space resource, time resource. Through the virtualization technology, various software and hardware resources in the data center are virtualized into virtual resource pool, and multi-user and multi-application share the data center resource. This is the Hadoop free in Big Data no, and I will introduce the works processing in the Hadoop free. First, the terminal sends a task request. After request is transferred to the resource manager from the terminal server, the resource manager is transferred to the node manager, and this ties. You can see that this phase, and this phase. At the same time, Yan open a virtual machine container through the scheduling and runs application master here. I make a mistake. The first type is for this and this one and this one. This application must will transmit introduction to resource manager and assign task to node manager of all servers through the map. This is this phase for that. The node manager opens up a virtual machine container and runs application must to pass the task to the data manager of its servers. After running requires, the data manager will reduce the result to name node. Here, the data node will run the task and reduce in the name node. This is the change. This is the change from above figure. You can see that the resource manager is standby in others hosts, not only in the one host, and the others host is standby also, and the standard will be monitored in Zoomkeeper. The design cloud recovery system is ordered to achieve the high availability. The system changes some part of architecture. The resource manager in standby is safe in every server except the active one, and same name node is standby in the same host. Zoomkeeper monitors the situation of the host. If the active host is suspended in short time gap, the one host in standby will become the active one and will keep the continuity for service. This is my performance indicator, RTO and RPO. Next part is for here, build and evaluate the recovery system. This part for data. This part is for environment configuration, and other part is for feature and how to evaluate the performance indicator. As for date, first we find the real date above the big account transaction record, but it doesn't need to save every column from the date as disaster recovery system. It should be clean before saving and backup, such as reducing date columns, calculating the total transaction and balance. As for simulation system, the best environment should be configured in base of system running, and then the Hadoop free will work in suitable environment to achieve the function. Next step, simulate the real signal in Hadoop free. As for special function, the clean date will be saved in HDFS, which is the part of Hadoop to save a backup date. In this style, the date will be saved in every virtual host, and then the date will extract the important information to be backup. This step will use the Hadoop system component. First, the container will open by YAM. The MapReduce text will run in the container. After the done in the MapReduce, the instructor, the date will be saved in every virtual host. As for the system performance, the system will simulate the real situation like system shutdown and check the recovery indicator in the process for recovering data. Let's say I calculate the RTO and IPO and then compare with the traditional cover system. This is the processing for how to evaluate the performance indicate in detail. This is configure the basic environment. You can see I will use the VMware, Linux, CharShell, and for the Linux I use the CentOS 7. This is after the configuring cloud environment. You can see that the Hardware 102 is active, 103 and 104 is standby. Next part is for the state of nodes. You can see in all nodes in this figure will run in the host. You can see that resource manager, name node manager, you can show in this figure. Resource manager, node manager, data manager, and so on. Next part is for MapReduce phase. In map task, first read the file through the import. You can see this figure. I will introduce this figure. Read the file through input format and split into the key value pairs. Key is the oversight and of life, and value is the line of date. You can see that this one is input and the format is depend on the input format, and you will be calculated in this phase, and this phase, and then you will output in output by output format. You will depend on the format which format you want, and then output the resource as a result. Sorry. The last part is result and discussion. This is the original date. It concludes the cluster or information. The date include 2A633 rows and 31 columns. But you know every columns is used for backup system. After the data cleaning, I just save the 8 columns in files. This is the file after data clean. You can see that the format is clean. The next part is the function of MapReduce. I do some function example in MapReduce. This is the code logic, and when you want to search information, you can input the key, and then the result will print the all information for this key. Next function is calculate all date transaction. This is the code logic. You can see that this is the all date transaction, but the more dates in bottle by just screenshot this information. And the next function is calculate the worker API. You can see that the files will divide into 3. Degree A is more than 10,000 API. The degree B is less than 10,000, but more than 3000, the gray say is less than 3000. This is the logical for this for code. The next part is verifying the features in high availability system. The first feature is high availability of data. The journal will send and receive the update data from database and send it for name node. This is the verb API for in file system. The data will be saved in Linux by block format. No one fails because the block is more efficient. It is high efficiency than the files. You can see that this is safe in Hadoop 102, safe in 103, Hadoop 103, 104. The next feature is task efficiency. Because you have many hosts in cluster, so the task will divide into every part for every data node. You can see this one, the task will divide into 3 parts for every active node. This the last one, but the most least point is system of high availability. You can see that after first verting, the name node 1 becomes active, but the name node 1 suffered disaster. The name node 2 will become active by second verting. You can see you can see the Hadoop 102 is active from active to unavailable, and Hadoop 104 is from standby to active, and the file system resource manager is running, so this is achieve high availability. Next part is measurement of RTO and RPO. The first for RTO, to simulate the situation that active host suffered the disaster when the disaster comes. First, monitor the host in real time, and then to kill the active host, which due to the simulate the situation is suspending active host. In this time, no host is active, system is suspended. You can see the Hadoop 104 is from active to unavailable. The next one, the second active host is running by second voting in Runkeeper and calculate the different value of date to get the result of RTO. You can see this is tie and this tie, and calculate the difference for this time. You can see the most appearance number is 5. And the next part is measurement of RPO. Hadoop API is using this search. Hadoop API simulator user claim in will upload the task date and will show time of updating and time of finish killing the active host. In order to simulate the situation is suspending active host. In this time, clean delivery file to disaster recovery system is failed. You can see when the Hadoop clean send the text 20 is failed. The browser file system inactive to check the last file backup and calculate the difference in their date volumes. You can see the date 20 is appear in the file system also, so the data never be lost. You can see the RTO always zero. The RTO always zero. The last part is computer vision with traditional disaster recovery system. The left part is traditional one. The right part is the cloud one. You can see the traditional recovery system consists of server access area, core switch area, and other switch area. But the cloud one only consists by hosts. As for cost, traditional one system require high cost for configuration. The Hadoop Cloud Disaster Recovery system only needs some servers with computing power. Compared with the traditional disaster recovery system in structure, this is much simple, which means that its cost is much lower than the traditional disaster recovery system, which needs to rebuild a bank's main system. At the same time, complete network structure also require high cost manual maintenance, but the cloud recovery system can achieve safe maintenance to reduce the cost. You can see that this is traditional one, and traditional one, and this is the cloud one. The cost is lower. For the performance, the RTO and RPO of this one are both greater than 1 day, which means that system survives need to last 1 day to recover, and the system date is at least 1 day short of date as most advanced technology of traditional recovery system and recover. At that time, SCADA still need at least 10 minutes to restore the system survives and at least lost the amount of data generally in 10 minutes. However, the instance of RTO disaster recovery system in Hadoop free only takes 7 seconds and most to recover the operate of system survives. In the data loss indicator RPO in research real, so the performance the cloud one is the best than the recovery system than the traditional recovery system. The conclusion: compared with the traditional disaster recovery system, cloud disaster recovery system has a simplified structure. The traditional one disaster system require a large number of data transmission equipment and require maintenance and management of this equipment, which lead to high hardware cost. However, the cloud recovery system only needs some basic hardware. This is why the cost of class 1 is low. As for performance, the traditional recovery system takes day as continuous unit or unit as the counting unit, but the cloud disaster recovery system in Hadoop free takes second as the counting unit. RTO and RPO has been inquired by thousands of times. Generally, cloud one is more cost effective than the traditional one. You can see this is the old comparison. About the future work, I think the cloud recovery system will get more performance, get more protection, and get more backup for data, and get more compatibility. Terima kasih. Thank you for your listening.